Welcome back. In this lecture, we will discuss the motivation for convolutional neural networks. And so by the end of the module, you should be able to describe how a CNN works. This particular lecture will give you kind of the intuition as to why the problem it's addressing is very challenging and important. Okay. So how do people reason about images? Well, you look at this image and right away you see it's a dog. And some of you may even be able to determine the breed of dog, that it's like a Shepherd Rottweiler mix. And so how can you do that? Well, you have the shape of its ears. You maybe pick out the forward nostrils on the nose is a big hint that's a dog. The fur on its legs. All these things, human beings instantly kind of pick out and assemble it together and say, oh, that's a dog. So it might make sense that we would maybe develop a, say, feature-based machine learning approach that would look at images and automatically extract features that are things that people would normally see. Maybe we have features around different kinds of noses or different kinds of legs and so on. But unfortunately, to generate features from images is actually quite difficult, and there's been years of research that have gone into this, and even when there are identified use cases where this works well, it turns out that those become very narrow, and this whole approach was very difficult to generalize. So this was a challenging problem for a long period of time. So the alternative idea was to use neural networks to reason directly on the images themselves and have those neural networks figure out what the features are all by itself. So if we just take an image, a high-quality image, we would have a couple of issues. So first is that most neural networks, they treat all the inputs interchangeably. So you take that picture of my dog on the previous slide, and imagine taking all the pixels out of the picture and stretching it in one big long line. Well, now you've lost a lot of information within the picture about which pixels are next to each other by doing that. So this is, your first issue, is the neural network will treat all these inputs somewhat interchangeably. And the second is images have a lot of pixels, so even just a simple 200 by 200 pixel color image, you're already talking about 14.4 billion weights to be learned, and that's a bit much for a small picture. Now, clearly, our neural networks today are doing this type of weight learning for very small images, or they wouldn't be widely deployed. So instead, the idea is how do we incorporate knowledge of the spatial structure into the neural network? And that's where we're going to start to look at, well, how do you build these features up? Can the neurons of the network start to pick out where there are ears, where there is a nose, where there are legs? And so the idea is we would want to scan through the image with some kind of sliding window. So just think of it, going iteratively through the image with a sliding window and just kind of seeing if we can detect if there's ears or if there's a nose there. And if there is, that's good information to know in determining what's in the picture. And we will use this concept that we'll introduce in the next lecture called a kernel to do so. So on that note, stay tuned, and we'll talk about kernels very soon.